Saturated vapor is condensed to saturated liquid in a condenser. The heat capacity ratio is CR, which is equal to C minimum by C maximum. The effectiveness of the condenser is, so we know that the heat exchanger effectiveness is defined as the ratio of actual heat transfer to the maximum possible heat transfer. So epsilon is equal to Q upon Q is the actual heat transfer upon Q max. Okay. Now there is a term called NTU. So NTU is the measure of effectiveness of heat exchanger. This NTU is actually number of transfer of unit, and the expression of NTU can be written as U times A, area of the heat exchanger, exposed area, by C minimum. Okay, the NTU is the measure of heat transfer size of the exchanger. Larger the value of NTU, the closer is the heat exchanger approaches its thermodynamic limit. Okay, and the capacity ratio in the problem it is given CR is equal to C minimum by C maximum. Now the effectiveness of a parallel flow heat exchanger is given by, so let's write PA parallel. So this is given by 1 minus e to the power of negative of NTU multiplied by 1 plus CR divided by 1 plus CR, where CR is the capacity ratio. Heat capacity, let's write heat capacity ratio. And for a counter flow heat exchanger, epsilon counter is given by 1 minus e to the power of minus NTU multiplied by 1 minus CR divided by 1 minus CR into e to the power of minus NTU into 1 minus CR. Okay. Now, if the fluid remains at constant temperature throughout the exchanger, then CR will be equal to 0, and by using this expression and the above expression for effectiveness of the heat exchanger, we arrive at the following common expression for parallel as well as for the counter flow heat exchanger, that is epsilon is equal to 1 minus e to the power of negative of NTU. If you substitute CR is equal to 0 on either of the equation, you will get this expression. So our correct option is option D. For more on this topic, you can refer to the NPTEL course lecture number 43, Epsilon Method 1 on Heat Transfer by Professor S. Dasgupta of the Department of Chemical Engineering at IIT Kharagpur.